Welcome, everyone. This is the CapX Industry Cast, where every other week after next week, we will be going live and continue to go live to talk about some manufacturing technology as well as personal development topics that are pertinent for our customers out there in the manufacturing engineering world. Our mission is to always be adding value, and one of the ways that we found to add value, especially during the COVID era, was to hop online, go live, and talk about some of the latest technologies that we've got out there in the industry. Super excited today. Bill Holtzman from MECCO has decided to join us and graciously accepted our request that he join Industry Cast. We're going to be talking about laser and dot peen part marking, specifically, when do you choose, which technology do you choose? Some of the surface challenges, some of the marking challenges that we see with both of the technologies, and just review in general some of the applications and, again, challenges that we see when trying to apply these technologies. So again, Bill has been gracious enough to join us. He is the sales and marketing manager there at MECCO. So Bill, tell us a little bit more about yourself.
Yeah, thank you, Russ. I appreciate you having me on. I love this Industry Cast series. I do watch it myself as well, so honored to be here today. I am Bill Holtzman, Sales and Marketing Manager for MECCO. I've been in the manufacturing industry now for about 15 years, in the laser and dot peen world for 11 of those. So I've been with MECCO that entire time.
Wow.
For the last 11 years, working with customers on solving some challenges, out in the field with laser and dot peen marking. So I'm excited to talk a little bit about that more today and kind of dig down a little bit into some of the topics that we hear a lot in the industry.
Where are you joining us from today, Bill?
I am out of Pittsburgh, Pennsylvania, born and raised here, and the office MECCO headquarters is in Cranberry, Pennsylvania. So I am back in the office, in and out, and happy to cast from the office today.
Yeah, awesome. Well, welcome. All right, so we will let you dive in. Again, this is kind of a free flow conversation. We'll be, cutting back and forth, asking questions, trying to get some clarification on some of the topics you're going to be talking about here today.
Perfect. Yeah, what do we want to talk a little bit about today? Some customers, they know they need to do some type of marking, or maybe they have something already in place and are looking to improve it. So, now what do you do? The wheels in your brain are turning. You're trying to figure out, you've been tasked with this project. How do you find a solution? With so many options out there, and I think more importantly, how do you choose which one to go with? So today we're going to break down some of those often overwhelming, bits of information to discuss some of the challenges that the engineers face that we see the most, and then the most common marking methods, and we'll break down how to identify which technology you're really going to need for your project. There's a lot of different ways that we can go about solving some of these challenges. There's a lot of technology out there in the marking world, and we're gonna look at those different methods and try to help give some guidance on what to look out for. Hopefully some people will relate to some of these challenges, and then how to overcome them.
Excellent. Yeah, that sounds perfect for our audience.
So this should be a little bit familiar, some of the challenges that engineers face. The first one is the cycle time. Productivity is a huge challenge, not just for engineers, but I think for manufacturing in general, especially now in today's world. Everybody's trying to speed up. How do we make this process to manufacture this part faster without sacrificing things like the mark quality or quality of the product in general? So when we're talking about productivity, we want to speed that up. We really look at what do we have to be able to not be a bottleneck in the overall machine when it comes down to identification of your product. So that's a huge challenge, and I'd say one that we see most often is can we improve on the cycle time that we're either currently getting with some other technology or with laser and dot peen in general. Same with the mark quality. People are putting marks on their parts for a reason, and there's a lot of different ones. It could be a logo for branding. It could be a 2D barcode so that you can track that part throughout the manufacturing process to identify steps in the process where they're at. It could be for inventory control. There's a lot of different reasons why they want to be on there, or it could be that part's going through something outside of the once it's done marking, and you need to maintain that mark for product recalls out in the field 10 years later, or it's going in a downhole tube and it's being pulled up in 15 years, and you need to be able to read a mark for product identification. So those are some of the challenges that they'll see. The permanence of that mark. Sometimes you just want to put a mark on a part that's going to last through your manufacturing of that product, and once it gets out the door, it's a different story. But a lot of times you need that mark to be there forever in the case of a recall, in the case of gray market, in the case of brand identity, so people can reorder your product, or you're just looking at something came back into the factory, you need to understand the history of that product. Sure. Then you have like pre and post marking. A lot of the challenges, okay, I have the product I'm manufacturing this way, and now I need to mark it. What do I do? I'm already, the part's coming into a cell and it's wet with coolant. I need to do a painted, I need to paint the part afterwards. So the mark has to be really deep so that the paint doesn't fill in the mark, or I'm going through heat treat. I'm going through these different processes. So that's something that manufacturers often have to do, is they've already have a manufacturing line. They're already manufacturing a product, and now they have to add marking in there. And how do we go about doing that? And then there's this data transfer, especially in today's world of IoT, smart manufacturing. How do we get information to the system to mark, and how do we get information out of it so that once we do mark, let's say a 2D barcode, we're able to track that not only internally, but send that bidirectionally from a database to a database, or removing human error from typing. A lot of different ways of approaching it. It could be an inline cell, it could be a standalone cell. And how do you want the information to be marked on the part given to the laser, and what information, or Peen, and what information do you want out of it? So those are the top 5 reoccurring, I'd say, challenges that are the first things that we really think about when it comes down to, can you mark it? How do we go about even starting to think about that? Will it be an improvement to the current process that we have?
So let's look, I was just topping ahead as far as breaking down each of these top 5 part marking challenges from a solution perspective. Now, slow cycle time. What are some of the options if we have a cycle time concern?
So if you have a cycle time concern, for example, for the laser side, we have, let's say you want to put a 2D barcode and some human readable on there, and you're using a 20-watt fiber, which is a versatile type of system that is going to be able to mark a variety of parts in different marks. But you need it to go faster, and you're just doing a surface mark. Well, a lot of times we can go up in wattages to a 30 watt, a 50 watt, 100 watt, a 200 watt even, to be able to take that same mark and reduce its cycle time by being able to speed up the rate that we're actually marking, but not sacrificing the quality because we have a higher power. So something like that, we would be able to use maybe a higher wattage or a different wavelength type of part. We'll talk a little bit, in a couple slides about maybe you want to go really deep, really fast. And one of the ways to do that is a hand stamp that you're hitting the material right now, but you want to make that faster, maybe even better quality. We would use a Peen and a deep, for example, to go really deep, really fast. Or maybe you're using a laser inline and you need to go deep and fast with that. We would look at breaking that down to the application side and working with lab engineers that would be able to change the settings of the laser to actually create the best paths for the beam to take to go and remove the material in an efficient manner. So more of a like mark optimization.
So from a point of reference perspective, let's say it takes 5 seconds to do a mark with the 20 watt. If we go to a 30 or a 50, and I know it's subjective, but
Sure.
what is an approximate expectation of a new cycle time or a reduction in the cycle time from 5 seconds to?
Yeah, normally from going from like 5 seconds, let's say from a 20 watt to a 50 watt, the average is about 46% cycle time savings.
Okay. So you can get down to about 2.5 seconds.
2.5 seconds. Yeah. So significant timing. Once you get beyond a certain point, the limitation is no longer the wattage of what you can do. It's how fast the mirrors can move in a laser. So you're limited more by the mechanics of the head than the mark itself.
Okay, that's good to know. All right, excellent.
So when you look at the different options that you have in marking in general, and I always say, if you ask a customer if they're marking their product, a lot of times they'll say, we're not. But when you ask them if like how they're identifying their product, well, then they have labels and inkjet and tags that are welded to a product or tied to a product. You have laser, you have that dot peen, you have chem etch, you have a lot of different options. And really, we break this down into two major categories. There's your indirect marking, which is more of like throwing a tag on there. Maybe it's a label where you're not actually directly marking the part itself. And then you have the direct part marking where you're typically not using a tag that you're marking, then putting it on a product. You are marking the product itself. And the way to do that, or why we do that, is because that's a more permanent method of actually identifying that product, where you have the label that can get peeled or fall off, or the tag that you have to do a secondary step, or same problem. You might have ink that would wipe away. But that said, there's a place for those type of applications as well. So we'll recommend and we'll take a look at applications depending on really what what you're looking to do. And a lot of this, and what we focus on, is the laser and dot peen marking, which is the direct part marking. We're directly marking the material, or putting a mark directly on that part.
Gotcha.
So with that, there's obviously a lot of paths that you can take to choose the right method for you. When we're talking about, the first thing is really trying to narrow down, are you looking for direct part marking, or are you looking for the indirect marking? And once you figure out the path there, that's the basic first step. Now we start to drill into, do you want, in our world, laser or dot peen? And there's a lot of different ways that we kind of go through that process to understand where does that path go. And for example, we were talking earlier about painting a part. What does that pre or post process look like? What does the environment look like? There's a lot of those questions that we'll go through to understand, is it an environment that is best, or an application that's best suited for which technology? Is it a laser? Is it a dot peen? Is it an inkjet? Is it a label? And that's kind of where we start, really high level of really understanding, what are the volumes of the parts? Does it make sense to make the investment into adding a full turnkey system into a cell for 100 pieces a year? So these are the kind of paths that we would take. First is the indirect versus the direct, and then we start to narrow it down into, do you want the laser, or do you want the dot peen when it gets to that direct part marking? Okay,
so let's do this yes no graphic that you've got here. So yes, do I have paint? Do you need to paint or coat after marking? Yes.
Yep, and even before that, we would look at the material, right? So you're looking at, okay, are we metal or are we plastic? Because that changes. Plastics are tricky because of the compounds that make up that material all react differently with the lasers. So if you're looking to do plastic, you can do that with dot peen. If you're looking for a non-contrast mark that you'll get depth in the material. If you think of a door handle, a lot of times if you were to remove that into pieces, there's a dot peen mark there because they don't care about contrast, and you just want to mark on the part that's permanent, and they can read it in the future. So once we go plastic or metal or some other material, then we bring it into those. Are they painting it? Are they heat treating it? Are they doing something like that? So if they are painting it, a lot of times there's usually, they want to go deep into the material, and that's usually, to go deep means cycle time. So more often than not, I'd say when you want to go really deep, really fast, and you're painting afterwards, it's, the 80-20 rule. 80% of those applications are going to go to dot peen.
Right.
You're just hitting that material, and you're creating that channel to create the character. And then you're painting right over top, and you get that depth in the material, and it's really, really quick. You can do it with a laser, but with the laser's following a path, and it's removing a small amount of material with every pass. So you have to do multiple passes to get the material essentially evaporated out of there. So generally it takes longer, or you use a higher power system, 100 watt, 200 watt, to go over that very quickly. You're removing a lot of material, and you're able to get really deep into the material really fast. The difference being there's there's some trade-offs. You have higher cost as the wattage goes up. You have safety. You might have a big part that you're painting, so you have some physical challenges or mechanical challenges. So so a lot of times it goes to the dot peen world when we're painting and even galvanizing after a mark. So normally that world is how we would kind of differentiate between dot peen and laser.
What about marking after the part's been painted?
Yeah, after the part's been painted, that's the opposite. So then that normally goes towards the laser side, because you're trying not to go through a paint or not to go through a coating. Maybe it's an e-coat that you want to stay on the surface of, or any kind of post-process where you're not, you don't want to disrupt, or it's right before the product is final and you're putting a laser mark, on that end. When you're physically hitting the part with a dot peen, then you have to worry about chipping or cracking the paint.
Certainly.
It's not going to look as good. Aesthetics
right.
into play. So more often than not, we just want to hit the surface with the laser, not go through it, just make a nice contrast mark so that, again, it's permanent. It's not going to go through the coating, and it's going to last for the life of that part.
Gotcha. Excellent. I like that chart. The benefits of direct marketing part marketing.
Yeah. So
direct marketing versus indirect marketing.
Yeah. I mean, when you're talking about, when you do decide and you go through that channel and you're deciding, okay, I'm going to stick with the direct part marking, and now you're at this funnel between laser and dot peen. There are some benefits that you'll get from either one. So, in either case, they're producing permanent and durable marks. On the laser side, super high speed for most of the applications. You're talking somewhere in the average of a 2D barcode and 3 lines of human readable that we see all the time, maybe 5 to 10 seconds to be able to get the data, mark the data, send the data if you need. So it's pretty high speed. It's great resolution. If you're marking something extremely small, like a 2D barcode on the tip of a spark plug, or even smaller than that, we have a trade show piece that we show that's marking the entire Gettysburg Address on the head of a penny that you need 100 times zoom to be able to read it. Very, very good resolution, very small marks. That beam is very small, so you're getting a really great mark out of that. And with a laser, you can get contrast on most materials. It might be a grayscale type of mark on aluminum or steel. You can get contrast on brass and copper, plastics. Oftentimes you'll get contrast on that. So if you're looking for a mark that's easily visible to a camera, the black and white that the camera's looking at, or to an operator where you want that contrast to stand out, laser, is the way to go there.
Yeah.
Minimal consumables, non-contact to the part, so which means that you don't have to fixture it the same way as if you're physically hitting it. And they're pretty versatile. You can mark wood, glass, any metal, a lot of different plastics that'll be able to get contrast on your part, or non-contrast, whichever is desirable. So you have a lot of flexibility in the laser side. On the
Of course, all of that flexibility comes at a price, and that's one of the drawbacks of that laser technology.
Yeah. And we have to look at too, you might be marking one part and it's the same part over and over and over again. But if you're a machine shop or you're doing multiple different parts and more of a one-off than all the same part over and over again, then we have to look at not only the flexibility of the system, but what wavelength would fit most materials the best. So because you have specific lasers that are at specific wavelengths that are great for specific applications, or you can go with like a general like a fiber laser that's able to mark 80% of the product that you're going to have. Your plastics, your metals, the fiber is not going to mark your wood or your glass. It'll go right through. But we try to understand what's the range, what's the mix of product that you have, how it's being presented in there, and what makes the most sense to capture the most amount of your product. And in some cases, the volumes don't justify the 100-watt laser to be able to mark everything. But the dot peen, you have that same permanent durable mark. These can be electric and pneumatic machines. You can go really fast with them. They produce a great mark, high quality mark. It's non-contrast, so you don't have that same contrast, but you get the flexibility of the fraction of the cost. They're durable. They can go into hard.
Why would I use pneumatic if I have electric available?
Yeah, so the trade-offs are really like when you're working with an electric machine, you have a solenoid that's effectively pushing the down the part, and it's not going to go as deep. So you lose depth with the electric.
Okay.
But you gain a little bit of the noise because with our heads, for example, we call it vibra peen. With a pneumatic head, we're forcing air down, pushing a cylinder, and it's spring returned. So you're firing that pin 80 to 100 times a second and tracing the outline of that character. With the electric versions, or what you'll see is dot peen out there, where you can see the distinct correlation of the firing of the pin, the movement of the stylus, and then another dot. So you see a dot pattern. That's a lot slower, and it doesn't go as deep. So electric, you gain the ability to use just electric, no pneumatic. It's a little bit slower, and it's not as loud. But with the pneumatic, you get a faster, deeper mark typically with that. So those are some of the trade-offs between electric and pneumatic. And some they call for it. Or if you're marking a tag, you might not want to. You don't need that. That force. So
sure. Okay.
So these are a lot of the considerations that we go through to choose a marking method. In general, and we kind of bucketed them in the three key categories. You have your materials that you have to consider. You have the manufacturing process that you have to consider, and then you have like how it's going to be integrated as a whole to consider. So when you're looking at the material side, immediately you want to look at the material type. Am I marking glass, for example? Well, for marking glass, then dot peen, you definitely don't want to hit that with the dot peen. So you're automatically in these type of buckets.
What are the common mistakes that you see when in each of these? So you've got the material, the manufacturing process, the integration. what is a common mistake in selecting the technology for your customers? What do you see?
I see a lot of times choosing the wrong wavelength, for example, laser, um, to mark the wrong, not the wrong product. You have a lot of different options to choose from a type of laser, UV.
How would they know that? Like, so they choose the wrong wavelength. Is that because they haven't had you do some testing for them ahead of time to verify and validate that that wavelength is going to be the right wavelength?
Yeah. Yeah. I'd say like a lot of people just, if it puts any kind of mark on and sometimes it's good and there's not a good way, it's like going after a one size fits all type of approach to marking. And in our world, there the different wavelengths, the different wattages, the different types. I mean, there's some really specific applications that we would help try to determine what is that best system. It's not a one size fits all. Let's look at your application and understand, what are you trying to do? Are you trying to get the contrast? Let's put that under the laser, see what makes the best type of mark, because you could be able to mark, let's say, a black plastic and it comes out khaki color.
Yeah.
And okay, it'll read, but a common problem would be it gets to, you're a builder, or you're running these parts for an end user. It gets to the end user site and the end user saying, well, I can't read these parts. I put a 2D barcode on here, I can't read them. But where you're manufacturing them, you were able to read every single one, but your camera is set up specifically to see a certain range. Whereas if you use the correct laser, it wouldn't maybe look khaki, it would look white, which then down the way, it's a better readability, which means user site, you get a better readable mark. And then it could be that, for example, you're in a medical application and you're marking a polycarbonate and you use a fiber for that, which will produce a nice, let's say, black mark on the product. Well, the way that the fiber is absorbed into that material, it creates a little bit of a like top surface type of it's a raised surface type of mark. Whereas if you used UV, for example, you'd get maybe the same contrast, but you would get a nice smooth texture to the part. So, and what does that mean for the customer is less bacteria buildup or an easier way to clean. So there are some applications that seemingly might not look like an advantage, like, oh, fiber, I get nice black mark. UV, I get nice black mark, but there are texture differences that might be important to the end user. And the only way to really know that is really to test out that product, try to find what works best in there, because there's a range of options. The best way to do that is working through an applications lab, really to throw it under the laser, try out different things, utilize the expertise of the lab to be able to really figure out, what that best.
It seems to me that it reiterates the importance of partnering with someone that's an expert, that this is what they do for a living. They don't have a one size fits all strategy. They've got multiple options and don't try to shoehorn you into something that's the only thing that they offer.
Absolutely.
We've got to keep rocking through here. So here are a few laser applications.
Yeah, I wanted to give some products. You have glass on the lower left. You have inside of an aluminum tube, some cast marking. You have plastic marking, stainless steel, a lot of different types of marks on a lot of different materials, and not only different types of marks, but different contrast with the same laser for different materials. So, we would look at the not only what type of laser is going to put a mark on, but then what type of mark do you want? How deep does it need to be? How dark does it need to be? What type does it need to look at? And even engraving or cutting, we look at that as well.
Yeah.
Dot, same thing. You have in that top left, that's the dots that you'll see commonly out there.
Right.
That creates a nice smooth channel. A lot of on the dot peen side, one of the things that is a common challenge is actually noise level. There are OSHA regulations on the noise, and we've seen that a lot of customers, especially when they're marking something hollow tube, something of the sort, we have scribe machines that instead of hitting the part 80 to 100 times a second and tracing the character, you're forcing a pin down and scratching the surface or tracing the character that way. So your decibels, you're saving 40%. You're going from 80, 90, 100, or 110 when you get into those hollow applications down to 60 to 80 max. So
seems like you go through a lot of tips with that type of technology.
you'd think, but it's a carbide stylus, so very robust. There is PM on there, and that's one of the consumable parts of the dot peen that you would go through, or the scribe, but nothing out of the ordinary, and pretty robust. Yeah,
Sure.
and you have your options. Okay, now you've put a mark on the part. You figured out what works best. A lot of times, customers are reading or verifying the part whenever they're done. It could be something as simple as just making sure that it scans, and that's a good judgment that whoever's going to be reading that internally is going to be able to read it at the next station. Or there's some integrated options with laser and dot peen that you would be able to mark the part, scan it, make sure that the data is correct, send that back to the database. This is really good for error proofing, because if you're marking a metal part, you can mark a 2D barcode in the same cell before it moves. You read the 2D barcode, make sure everything looks good. It grades properly, which is a good estimate that it's going to have a long life. And if it doesn't, for whatever reason, you either know that there's a problem, or maybe there's a defect on the part. Have the opportunity to mark it again while it's still in the cell. You basically erase the code, put a new one on, test it again. If it passes, it passes. If it fails, you can go right to a reject bin and analyze what happened. So a lot of different options.
Yeah, that seems like that would be a real benefit there. Obviously, that increases your cycle time. You lose one cycle in that process, but it helps to ensure that you've got a good part hitting out the laser.
Yeah, and what we talked before, a lot of different customers are going to be in a lot of different places when they're going to be marking. Some of them have equipment on the floor already. Some are new customers. Some of them have marking technology. Some of them don't. And they're just getting into it, maybe forced by regulation. So at any point of your journey, I think looking at a partner to help understand what you're doing, develop that full picture with you to really look at a holistic approach to marking, because it's not just throwing the mark on the part. There's a lot of those ancillary things that we look at to determine, do we go laser? Do we go dot peen? Do we go with completely different technology? What type, what, lens, what wattage, everything. And get help with the lab, like we talked about, on really understanding the best fit, for you. So that's a lot of the challenges and some of the things that we think about and see and can do in the marketing world.
Absolutely. Well, thank you for sharing your wisdom. I think it comes back to partnering with someone that knows what they're doing. It's so important. And regardless of the technology, it's really important that you choose someone that's been there, done that, has the experience, can help you avoid the mistakes that you're going to make if you try to go it alone. I see a lot of customers, they try to go it alone because they don't want to pay the price. It's an investment to work with someone that knows what they're doing, but the savings in the long run will surpass in the headache, in the savings of the headache, because that's the bigger challenge. You've got all kinds of things to do. If you're a manufacturing engineer, you've got the line that you're responsible for, maybe some new products coming in. You've got some product updates that have to be, some tooling changes and things like that. So there's just so many balls that you have to keep in the air as a manufacturing engineer. Give it to someone that knows what the heck they're doing and allow them to do what they do. And that's what MECCO does, is they know what they're doing. And so thank you again for taking the time today, Bill. Very helpful. Any final words for the viewers?
Yeah, I just appreciate being here. I appreciate you listening. Certainly, if you have any questions, reach out to the team. We'll be happy to work with you to really try to understand where you're at with marking, what you need, and hopefully we'll have a solution for you.
Fantastic. All right, next week, the 23rd, I believe it is, we are going to be having a conversation with Dave Kralovitz from Cincinnati Test Systems, speaking specifically about medical part leak testing. So don't miss that. Of course, after you leak test it, you're going to want to laser mark it. So there's a
Love it.
special application for that, so we don't grow bacteria on the medical parts. So maybe we're going to use what technology we're going to use there.
Let's try UV. Let's go.
There you go. So, all right, everyone, thanks so much for joining. Appreciate the opportunity to serve you. We are blessed. We thank you for the opportunity each and every day that we get to serve you.
Thank
Cheers
you.
for now.